Now I'm going to cover sampling methods. There's 4 that we have to learn. And after the sampling methods, I'm going to kind of create a summary sheet or just to start some review here, okay? So sampling methods. These are ways for us to get a sample that is supposed to be representative of the population, okay? Okay, and so let's see. We have simple random sampling, SRS. Okay. So simple random sampling is you have a list of every single person. This is called the sampling frame. Okay. And then you select from that list one by one, or individuals one by one at random. Okay. And what this does is it makes every single possible sample have equal probability. Okay. Okay. That's simple random sampling. Okay. Is that okay? We have systematic sampling. This is best for lines or queues. And what you do is you select every nth person in line. So like, for example, every 10th person or every 9th person. Every etc. etc. Yes?
What does it say? Select every
nth person. N being just a whole number. So every 10th person or every 7th person, whatever number you pick. Okay? So that's people are going through in a line, and you're just going to say 1, you go, and then 2, 3, 4, 5, 6, 7, and then 1, the next person goes, or something like that. Yeah. Yes.
What is the word best for lines or
Queues.
queues? Thank you.
Right? Like if you form a queue behind, I don't know, customer service phone call center. Yeah, every nth person. Nth. We haven't heard this before. Every nth, every umpteenth person, something like that. Okay, it's just a stand-in for a number.
Like X.
Yeah. Is that okay? So that should also give you a representative sample. Okay. We have stratified sampling. Okay. The population consists of subgroups, okay, based on a certain trait. Okay. And we know, so certain traits, so for example, you know, gender or race or whatever it might be. Okay, so the population is divided into subgroups. So maybe you're dividing the population by gender, and you say half are male and half are female. Okay, and so we must know, or we know or presume to know, the proportion of each subgroup in the population. So for example, you know, male 50% and female 50% or something like that. Okay. And then when we select our sample, okay, we randomly select individuals but also force our sample to have the same proportions that exist in the population. So for example, okay. So for example, if we did stratified sampling, we would force our sample to be 50% male and 50% female. Okay. Whereas if it were purely random sampling, from random sampling you might get, you know, 45% male and 55% female or something like that, just because it's random. But with stratified sampling, you say, in the population, I know these proportions exist, and I'm going to force my sample to have the same proportions. Any questions on that? All right, and then lastly, we have cluster sampling. Okay, so in here, the population consists of subgroups it is difficult to get a list of everyone, It's difficult to get a list of everyone in the population, but not difficult to get a list of the subgroups. Okay, so what you do is you randomly select from the list of subgroups, randomly select some groups from the list of groups, and then perform sampling, either sample everyone or perform random sampling within these selected groups. Okay, so for example, we want to get a sample of people who go to church. Okay, so maybe it's a list. It's difficult to get a list of everyone who attends church, but it's relatively easy to get a list of all the churches. Okay, and so we randomly select some churches from a list of churches. Okay, and then we perform random sampling within those selected churches. All right, is this okay? So we have simple random sampling, stratified sampling, cluster sampling, and systematic sampling. We have 4 sampling methods. Okay. So if I describe a scenario to you, will you be able to identify which sampling method is being used? Okay, so can I go? Okay, I'll let you guys get caught up on writing there. Okay, so maybe I'll just write some stuff on in a Word document because it'll be faster. You don't have to copy this down. These are just kind of exercises to get you guys to do some thinking. Okay. So let's try this out. Okay. Okay. An organization. So you don't have to write this down. Okay. Just read it and then think about it. Okay. An organization is made up of 4 departments. Okay. Each department is approximately the same size. Okay. To get a sample of the organization, the researchers choose to get a sample of 400 people total and randomly select 100 people from each of the 4 departments. What sampling method is this? Okay, so don't shout out the answer. I want everybody to think, but don't shout out the answer. Just think which of the sampling methods we have. We have SRS, stratified, cluster, systematic. I'm sorry, I put them in the order in your notes is this. Okay? Alright, does everyone have an answer in mind? What do you think? Okay, what is our answer?
Cluster.
The answer is stratified sampling. Okay? Alright, so from here we know, right? Each department is approximately the same size. So each department consists of about 25% of the organization total. And when we choose our sample, we're making sure each department is equally represented in our sample. Is that okay? All right, let's try another one. Okay. A shopping center wants to get random surveys or opinions from their customers. Okay. Every time a customer checks out, the computer counts is how many people have checked out. It then selects every 15th person and to check out to receive a survey of his or her opinion. Okay, don't shout out your answer, but think. What method is this? Okay, go ahead. Systematic. Okay, let's try another one here. Okay, there are, let's say, 290 Little League teams in, I don't know, some division, in the division, okay. To get opinions of players, the organization randomly selects 20 teams and then surveys all of the players on each of the 20 selected teams. Okay, so in this scenario, what sampling method do we use here? This would be cluster sampling, right? Okay. All right. Here, let's try this. Okay. There are 290 Little League teams in the division. Each team has, I don't know, okay. To get opinions of the players, the organization gets a list of all the players on all the teams. It then selects 150 players at random from the list of all players. Okay. Oh, so in this scenario, what sampling method do we use? Yeah, so this one is simple random sampling. So the key here is that we have we have a list of all individual players. Okay?
You said, what was the key there?
We have a list of all the individual players, right? The organization gets a list of all the players on all the teams. Okay? All right. Let me figure out how to get these into your notes. Okay. All right. So that's that for sampling methods, and we'll start our notes for review. Okay. Okay. Oh, so so this week your homework again is to do the practice final exam. There is a study guide printed. Okay. So I kind of want to show you that, and we'll go over that. There's a study guide available in the and this just asks you some questions, okay? So, yeah, very importantly, in the beginning, we got to ask ourselves, is the situation we're dealing with, are we dealing with proportions or means, okay? And do we have one sample or two samples, okay? And so, if you're dealing with categorical variables, you're dealing with proportions. If you're dealing with numeric variables, you have means, okay? Or quantitative variables, you're dealing with means, okay? So let me, what is this? I guess that's fine, okay? So means or proportions. Categorical means you're dealing with proportions, okay? And if it's numeric or quantitative, you're dealing with means. That's what we've got, okay? Also, as you're reading, you know, it'll list off things like if you see a standard deviation in there also, okay, then you're dealing with means. You're not going to have a standard deviation if you're dealing with proportions, okay? So other things. As you're reading the problem also, you have to see if you have one sample or two samples, okay? If you want to say you have two samples, you've got to be able to identify two sample sizes. There needs to be listed two n's in the problem. Okay, two sample sizes. If you can't identify two sample sizes, then you just have one sample. Okay, so once you figure that out, that will guide how you will be answering your questions. Okay, and then the next thing is, all right, when you read the questions, it'll either say, do a hypothesis test. Okay, it'll ask like, what are the hypotheses or things like that, or it'll say make a confidence interval. All right, and again, the calculations that you do for whether it's a hypothesis test or a confidence interval will be different. Okay, so you want to make sure you're using the correct one. Okay, so here it says for problems about confidence intervals, okay, you should be able to answer the following questions. Okay, what's the center of the confidence interval? Okay, and it lists off for one sample proportion, the center is going to be p hat. For one sample mean, it's going to be x bar. For two sample means, it's going to be all these things. Okay. So anyway, as you go through, of course I'm biased, and of course I'm going to think this, but I think this study guide or this this guide to doing inference is helpful. Okay. So these kind of list off what are the questions that you might see in a question, and then and it lists off these are the things you need to know. Okay. So use this. The front side is for confidence intervals, and then the back side goes over hypothesis tests. Okay, it covers all of these things here. Okay, so I'm going to kind of just put a lot of things into. I'm going to also summarize them here as well. And however, whatever you decide to use for the final exam, that's fine. Okay, on the final exam, you're allowed one sheet of paper, front and back. Okay, so if you want to kind of give yourself practice this week, see how much of the practice final exam you can do with no other notes other than one sheet of paper, front and back. Okay. If you want to use the study guide that I have printed online as your sheet of notes, front and back, that's fine. You can even write additional things on that paper as long as what you're using is one sheet front and back. I can't let you have multiple sheets. Okay, just one sheet front and back. You can have whatever you want on there. Yes, question?
You mean on the final?
Yeah, on the final. Okay.
Okay.
Yeah.
Does it have to be handwritten or can it be typed?
It can be typed. Okay. Anything goes. Yes.
So how much of the final is going to be things you learned recently? How much is going to be things from the past?
My estimate's about 75–80% is things we've learned recently, and then about 20%, 20 to 25% stuff from before the midterm. Okay? Yeah.
So is there going to be random homework questions from any of those?
So the older questions will be conceptual, no non-calculation questions. You'll see a few examples at the end of the practice final next
So there
week.
won't be calculate the z-score for.
Well, you got to calculate z-scores for this stuff. Yeah.
So anything we need to know is on the practice file, essentially.
Yeah. Okay.
Not anything for students. It's private.
Yeah, I'm not out to get you guys. All right. I'm trying to be as helpful as I can to do well. So of course I think the thing is fair because that's my goal. But I think it is. So okay. All right. So let's just do a quick recap of confidence intervals, and then we'll do hypothesis tests. Okay. So confidence intervals. We've covered confidence intervals for one sample proportions. Okay. One sample means, and then two sample means. Two samples means. Okay. And all confidence intervals are in the form of the center estimate plus or minus critical value times standard error. Okay? All of our confidence intervals are like this. Okay? For one sample proportions, the center estimate is p hat. Okay? P hat, what is p hat? P hat is your sample proportion. Yeah, proportion in the sample. Exactly. Your critical value for one sample proportion is z star. And how do we pick out z star? There's 4 numbers to memorize, right? Okay. 1.28, 1.645, 1.96, 2.58 for 80%, 90%, 95%, 99%. Okay, and then the standard error, p hat times 1 minus p hat over n. Okay, this is an interval for p based on our sample. And in the end, we make conclusions like, I am blank % confident that the proportion of people in the population, okay, and it's always about the population, never about people in the study or people in the sample or anything like that. Proportion of people in the population who blank or whatever is between the low value and the high value. So I'm hoping this looks familiar. Good. Smiles and nods. I like to see those. All right. One sample means same thing, okay? This is an interval for mu, and in the center, what do we put? X bar plus or minus t star times s over the square root of n, right? X bar is our sample mean. T star comes from the t table. With n minus 1 degrees of freedom. Okay, this is an interval for mu based on our sample. And we say stuff like, I am blank % confident that the mean whatever in the population is between blank on the low end and blank on the high end. Okay, and if somebody asks, do we have evidence that it is different from 20? What are we looking, what's our answer based on the interval? So if 20 is inside the interval, we say what? Okay, someone's asking, do we have evidence that it's different from 20? 20 is inside the interval.
We don't reject.
Yeah, we say no, we don't have evidence that it's not 20. If 20 is outside the interval, we say we do have evidence that it's not 20. Okay. All right. 2 samples means. So far, so good? Okay, we in the center here, we have x bar 1 minus x bar 2. That goes in the center. Plus or minus our critical value. Still t star. And our standard error is just now this s1 squared over n1 plus s2 squared over n2, all inside the square root. Okay. This here, this is our difference between sample means. Sometimes this is called our observed difference. Okay, this is still our center estimate. Plus or minus t star still comes from the t-table. With n minus 1 degrees of freedom, use the smaller n. Okay. And it's an interval. For the difference between mu1 and mu2. And I would say I am blank % confident that the mean, whatever, of group 1 is between blank low and blank high, more or less than the mean, whatever, score of group 2. Okay, so the mean age of group 1 is between 10 and 20 years more than the mean age of group 2, or whatever it might be. Okay, fill in the blanks. Is this page okay? Yes? Alright, so then we'll do one more page for hypothesis tests. Okay, so this side is all for hypothesis tests, and so we will do hypothesis tests for one sample and its proportions. Let's see. And we're going to do a hypothesis test for 2 samples, proportions, hypothesis test for one sample means hypothesis test for two samples means. Okay, so the hypothesis for one sample proportions is that P is equal to some number, and I'm just going to throw in some number 0.25, okay? But of course not necessarily 0.25, okay? And then the alternative is that P, I don't know, doesn't equal 0.25. But of course, not necessarily 0.25. It might be greater than, less than, or not equal to, right? Anything there is possible, okay? You calculate the test statistic as P hat minus P0 divided by the square root of P0 times 1 minus P0 over N. Okay? This part on the bottom, this is our standard error. Is that okay? And then what do we do with our test statistic? We look up the test statistic in the Z table. Okay? And we have the same rules for everything. If the alternative has greater than, take the area to the right as the p-value. Okay? If the alternative has less than, I'll say p-value equals area to the left. And if the alternative has not equal to, then what is our p-value? P-value equals 2 times the area away from 0. And I'm hoping this looks familiar. Any questions? Yes?
For those last two sentences, is there like an equation for each one? Like one of those like 1 minus something? Or...
Well, area to the right means 1 minus area to the left, right? The table always gives you area to the left, so area to the right is 1 minus area to the left. But other than that, I don't have equations. These are just the concepts you got to know. Okay? Hypothesis test for two samples, and we're dealing with proportions. Here we've got P1 equal to P2, okay? Or equivalently, it can also be written as P1 minus P2 equal to 0, right? Okay? The alternative here, P1, is greater than P2, or, whatever other symbol that you want in there, okay? P1 minus P2 greater than 0, okay? Your test statistic is going to be P hat 1 minus P hat 2 divided by the standard error. The standard error is equal to the square root of P hat times 1 minus P hat times 1 over n1 times 1 over n2 plus 1 over n2, okay? And we said p hat is equal to x1 plus x2 over n1 plus n2. Sorry, let me just rewrite that a little bit bigger. Okay. So there's no 1 or it's not p hat 1 and p hat 2. It's p hat times 1 and minus p hat, and you've got to figure out p hat like this. Okay. All right. Find the p-value the same way as over here. You take the p-value from the z table, same way. Good? All right, let's do a hypothesis test for one sample means. We're almost done here. Mu is equal to some number. I'm going to just make up a number, 42. And then the alternative, maybe mu is less than 42, or whatever it might be. Okay, your test statistic is going to be x bar minus whatever mu appears in your null hypothesis divided by s over the square root of n. Okay, and then you look up your test statistic in the t-table. Okay, use degrees of freedom equal to n minus 1. Always round down if you can't identify cannot identify it. Okay. You know what? I always forget to do this. Let's actually take roll for once, huh? Does anyone have a blank sheet of paper that I can? And then we'll pass it around. You can write your name on it. Okay, thank you. Okay. Sorry. So thanks for sticking around. Okay, just be sure to number. Okay, there's 22 of you here, so there should be 22 names when it gets back. Okay, always round down, and the way we do it, you guys know how to do it, is you figure out which column your test statistic is between, and then the corresponding p-value will be between the column headings.
Is it always between columns?
Or not necessarily. I don't know how to summarize using the t-table in like one sentence here, but you guys know how to use the t-table, right? We covered that last week. So okay, so I think I'll just leave it like this. All right, and then hypothesis test for two sample means. We'll do mu1 is equal to mu2, or it can also be written as mu1 minus mu2 equal to 0. Okay. And then the alternative, is that they're different or something like that. your test statistic is going to be x bar 1 minus x bar 2 divided by the standard error, which is s1 squared over n1 plus s2 squared over n2. Okay, and again you use degrees of freedom equal to n minus 1 and use the smaller n. You've got two n's, use the smaller one. Okay, and you look up test statistic in the t-table. All right, and so that kind of summarizes all the different pieces of hypothesis testing. At the end, the conclusions you make are always okay. Does everyone have this? Yes? No? Okay, I'll give you another minute. So, and then I'll just do one more page, which shows the conclusions. Based on how the how the p-value compares to alpha, whether you reject or not reject, and do you have evidence, do you not have evidence, all of that stuff. So there's one more page, and then we're all done. So I'll let you guys. Okay. So sign-in sheets should be coming around. Thank you guys for sticking around to the end. Okay, I'm going to go to the next page. All right, so our conclusions, and this applies to all of our hypothesis tests, right? Okay, so if the p-value is less than alpha, that means we reject the null hypothesis. Okay? This means we have evidence to support, whatever the claim of the alternative hypothesis. So if the alternative hypothesis says, do you have evidence that it's different from this, or evidence that it's greater, or evidence that it's less than something, that's what happens, okay? When you reject the null, you have evidence, okay? Rejecting the null corresponds to having evidence. On the other hand, if the p-value is greater than alpha, we do not reject the null hypothesis, and that means we do not have evidence. Oh, I said do have. It's we do not have evidence. We do not have evidence. It's an important word. Okay, we do not have evidence to reject the null, or there's two ways you can also write this. We do not have evidence to support the claim in the alternative hypothesis. Okay. Yes?
does that mean we have evidence to support the null hypothesis?
Yeah, no.
Yeah.
That is,
So we don't
yeah.
have any
Okay. Yeah, so do not rejecting the null is always associated with not having evidence. Okay? You can never say I've chosen not to reject the null, therefore I have evidence for this. Okay? So just like the juries, if they choose to not reject the null, they say we find the defendant not guilty. They never say we find the defendant innocent. Okay, so you always have to say the defendant is not guilty. So that's that. Okay. All right, that's everything. We'll end right here, just a few minutes early. Make sure you sign in on the sign-in sheet that's coming around. Who's got it? Okay, did everyone sign in? Okay. And with that, have a good night. We'll see you guys next week.